Right, bring you back. We've got the pulley set up in the toss lathe. So this is the small pulley that I took off of the 1.5 horsepower motor. So with the Harrison lathes, there was a few options. There was the 1.5 horsepower 1400 RPM motor. That'd give you 750 with this pulley. There was the same motor with a larger pulley, like a 90mm pulley. That'd give you about 1000 RPM. There was a 2-speed motor with this pulley, which would give you, sorry, not a 2-speed, a 2-pole motor with this pulley, which would give you 1500 RPM. And then there was like the sort of the top of the range model, which was a 2-speed motor, 2-pole, 4-pole, and that would give you 1000 RPM and 2000 RPM. Well, for what I do, 1000 RPM is probably going to be fine. And obviously our motor's only a single speed motor, but we could overspeed it with a VFD. But when I do end up putting a VFD on it, I'd rather not have to overspeed the motor massively. So if we just go with a slightly bigger pulley, which will be a 90mm pulley, that will give us that 1000 RPM. But I want to bore this out anyway, just to use in the meantime. So we've chucked it up in the lathe. I've ordered a taper lock pulley and taper lock bushing that is going to be of the right dimensions to give us that 1000 RPM, but this pulley's doing nothing. I thought I might as well bore it out to 28. So you can see we've got, I don't know, what's that, 6. There's a bit of run out in it, 0.06. So 60 microns of run out. It's not a lot really. I'm going to put some torque on it and see if that'll improve slightly. Let's just undo it slightly, get it back up. 0 in, off. That's better. A bit better anyway. 4, 5. Right, 40, 50 microns run out. We can live with that. It's only a pulley at the end of the day. Right. We're neutral. We'll go for 500 RPM since we're doing alley. Should be 500 there. It's about 500 RPM. We'll just take a skim. Right, so we're going to take a cut of 0.4. Bore 24.8 roughly now, give or take. If it's a telescoping gauge or set gauge. There you go, 24.808. So that's our dimension of our shaft on the motor. So it's ever so slightly under nominal. And what we'll do is we'll give it about 10. I'll have to check, but we'll give it between 10 and 20 microns of crush, and then that'll be a decent interference fit. Right, excuse the mess. So we got the pulley bored out to size. This lathe does turn a taper and it's a pain in the arse, hence why I didn't want to use it. So we've got it set up in the Jones and Shipman press, and now we're going to broach the keyway back out to the proper depth. Obviously there's a little bit of the keyway left, so we've just had to align it, put the bush in, away we go. So we're going to stick some oil on it and we'll start broaching. I think you can see the broach there. This is just roll coal cutting fluid. So we get plenty of that. On aluminium, obviously the fluid's more for guiding it through the bush than doing the cutting, but we'll stick plenty on there as well, and we'll give it a little douse in that just to keep it going through. There is no better cutting fluid for aluminium than WD-40 really, or paraffin. So just follow this through. I've got a pot to catch the oil and the broach, so that broach is through without any shims. As I say, the keyway was obviously already existed. Push this broach through. Right, that broach is through. Pull that out. So I've just got a pot under there to catch the excess oil. So stick the broach in again with one of the shims, and I believe the two shims for these are the same thickness. They are. So we just give it a bit more oil again, and particularly on the back with the new shim. Like so. We'll square this up here. Eight mils kind of the limit of this arbor press really, on aluminium as well. I don't know if you do it with steel. It's not a ratcheting press or anything like that, it's just a normal, obviously there's a gear reduction, but it's nothing like a ratcheting press. This is about 3 ton max, I think. So that's that one. That's a better depth, but we need to go a little bit more. So we'll stick another shim in there. Give the shim a bit of oil. Clean the chips out. This one. These are so dear, these broaches. You really need to take every sort of precaution to maximise the life of them. We had one supplier of broaches in the UK that made, you know, standard box sets, and that was Marco. And Marco is now owned by a company called WDS Components, and they are beyond expensive. You're talking over £1,000 for a box of broaches with maybe 4 or 5 broaches to do, say, 3mm up to 8mm, which is what this Dumont set is. So the imported Dumont set is cheaper than purchasing a UK made set of broaches. You could buy Chinese broaches, but I try not to buy Chinese anything. I just don't like the idea of it. I'd much rather support a British company, but you can only do what you can do. So there we go, USA gets it. If anyone else knows good companies for broaches or even sharpening broaches in the UK, I'd love to hear them, because these are so expensive. we've got to get this started straight now, which is always the hardest bit. So you can turn the broach around, which isn't a bad idea. It needs a bit more oil. That just allows it to centre itself. It's cutting nice now. It's the only problem is press the travel, and there goes that broach plug. The travel runs out just before the end of the broach normally. Which you can sort of change that, and the method of doing that is to cut the legs down, which you do see that done on quite a few of these Jones and Shipman presses, but this one hasn't been, which is handy because if you want to use a larger broach, then you can't do it with the shortened legs. So that's well, when we get this broach out, come on, it's a bit tight on that keyway there, but there we go. Take our shims out. So that's our Demont broach plug. So we've broached that keyway, and it looks like it's tapered a bit again, which it does have a tendency to keep doing with this 8mm plug for some reason. It tends to make a deeper keyway at the back or the bottom than the start, and I'm not sure why that is. Okay, so that's taken about 30 minutes of pissing about to get that motor on and bolted up and levelled and get the electrical connections on. I had to crimp the electrical connections first, which took about 15 minutes, 10 of which was finding the epoxy crimper. So anyway, I'm just warming the pulley up now, ready to drop on. I'm just going to quickly put a bit of emery cloth on that shaft while it's spinning, just to give it that final clean up and get the rest of them burrs off, and then we'll get the pulley on once it's up to about 100 degrees. 240 grit emery. The motor's been wired up and is running the correct way, and we turn the power on. There it is running. A little bit noisier than my old motor, but not by much. I'm going to use this emery cloth. This is a bit of 240 grit to just polish the end of that shaft. Take some of them burrs off. Yeah, that's better. Just wanting to make sure there's no high spots, anything that's gonna drag on the pulley we're gonna install. That's better. This is our hot plate we use for warming up bearings and pulleys and sprockets and flywheels, all sorts, anything that goes on there. It's about 12 inches by 9 inches, and it's a laboratory hot plate, Clifton. It's a good brand, goes up to about 300 and something. It gets piping hot, but about just over 2 to about 150. So what we want is 90 degrees between ambient and the component, and that will give you just enough growth for a bearing to drop onto a shaft. But as this isn't a bearing, we can go a little bit hotter. We can go about 150, and just over 2 is about 150. So that's been on there for, oh, I don't know, 10 minutes. I would say that's at about 60 to 80 degrees now. You can just about touch it. We'll give that a couple more minutes and we'll put it on. Right, so we've got the sprocket, we've got our heat resistant mitts. That's how it's done. That's actually gone a bit too far, but we soon push that back. Right, so we're at the lathe. The motor's on. We've got the belt tensioned, I guess. Hopefully it's all still in line. After tightening them things up, we can sort that later. If not, but let's give it a go. Noise is about the same. The motor's a bit louder, actually, but then again, of course, yeah, it comes up to speed quick. Clutch is still working all right. Speed at the minute is obviously still the same, 750. That's 480. The rattling noise comes from the clutch. I don't quite know what causes that, but there is still a bit of belt slap. By the looks of it, the belt's still slapping about a little bit. Yeah. Forwards and reverse works well. Definitely makes the lights flick a little bit more though, his motor, when going between forwards and reverse. Beautiful. Very good.